OpenQP team. In this part, we will take a look at input structure in OpenQP and how to use wiki to find new keywords and the keywords you need. And the next video, we will take a look at input log file structure in OpenQP. So I think it's better to start with some simple calculations like Hartree-Fock for water molecule. So if you have cloned OpenQP, you can go to examples folder and you can find different type of calculations here. You need Hartree-Fock. Alright. Let's start with the simplest. Also take a look at gradient calculation. Okay. Alright. As you can see, this is the full structure of OpenQP input file. It has some sections like input, guess, SCF, and others. If you want to see all of sections, you can go to our wiki in user guide and input file system. You will see all of the sections and all of the keywords as well, and the explanation they have and different ways of using them. So in here, for this Hartree-Fock 631G star RHF calculation, you can see OpenQP asks for your system's geometry. You can either put it like this here in a standard format 8 or just O H something like this, or if you want to do something more systematic and more professional, you can save your input in XYZ format and just get rid of this part. And here say like wherever you have saved your geometry, you can enter it like this, and OpenQP automatically will read and use it. After that, in this input section, you have to specify the charge of the system, the run type, which here is energy, and you can see here is gradient. Then the basis set. The basis set format is exactly like what you can find in Basis Exchange webpage or Basis Exchange Python library, so don't worry about it, you can find all of them there. And then the method, if it's Hartree-Fock or time dependent Hartree-Fock, which in this case is Hartree-Fock. In guess section, you can specify different guess options you have. Here you can find them here. Let me. Okay, the type can be HUCL, HCore, Molden, which is not recommended, or JSON. I will talk about how to use the JSON file as guess and how to save the information of molecular orbitals and then use those information for new calculations, so don't be worried about them. This is the default, so you can go with default. And in SCF section, you have to specify multiplicity and the type, which multiplicity for RHF restricted Hartree-Fock is 1 here, as well as for gradient. Let's see if okay, that's enough. We will take a look at this input options a little bit later. And for gradient in properties, you have one more option here, grade equal by 0. There are different numbers you can specify for this one, but for Hartree-Fock and RHF Hartree-Fock, you have to put it 0. Let me. Okay, properties you can find here, and gradient specifies the state of gradient calculation, and you can see that the default is 0, but you can change the number up to 2, I guess, and for different type of calculations. After that, you can simply save your inputs. This is the whole structure for the simplest type of calculation, which in future we will take a look at each input more comprehensively, and also we will take a look at log file structure. Then we will go for more sophisticated type of calculations. Alright, so simple, you can say OpenQP, run RHF, energy, hope it works. Yep, my environment is working correctly. So now the calculation is done, and as you can see, there will be a couple of outputs, like the JSON file, the Molden. You can use this for visualizing your molecular orbitals and different properties using external softwares, and the log files, which we will take a look at in next video. But the whole structure will be something like this. I will explain it later. Okay, thank you. Have a nice time.